Welcome. The last several days we've spent a lot of time talking about dimensional analysis, and ultimately I wanted to point you today in the direction of understanding why it's so important that we use dimensional analysis in chemistry. As we move forward and as we are finishing this unit and getting ready to start on the next unit, we're really going to start into, what exactly chemistry is and how exactly we're going to be using chemistry as we are moving forward. And so I wanted to kind of tie those two units together, kind of transition from, where it is that we're going to end as we finish this unit on measurements and calculations, and where it is we're going to begin as we start the next unit looking at what we call atomic structure and understanding what atoms are, understanding what matter is, understanding how things come together and work in the world around us. So with that in mind, what I'd like to do is I'd like to spend some time today looking more at chemistry and dimensional analysis and showing you exactly how we use it. And so let me just give you an example. Let's pose a question. So on the board in front of you, as you're looking at this table, this slide, you're going to notice that on this slide I have actually a question posed to you, and that question is, if I measured, so at the very bottom of this slide it says if I measured out 25.24 grams of sodium, how many moles of sodium would that be? And now you're thinking, well, I don't even know what a mole is, right? We haven't actually talked about moles yet in this class. We haven't really spent any time looking at them or how we use them exactly. So that's what we're going to start looking at today, is exactly what it means when we're talking about, chemistry and how we're going to use what it is we're going to be looking at. Let's just consider the question that I just mentioned. What if you had measured out 25.24 grams of sodium, and the question is, how many moles of Na do you have? You couldn't just move that up and down a ladder, right? It's not simple as changing milliliters to liters or changing grams to kilograms or anything like that, or even any of the other conversions that you've been given thus far, dealing with either the metric system or even the not metric system, the English system. And so as we consider how we're going to go about solving a problem like that, there's some information we're going to need to know. Specifically, we're going to need to know, what does it mean by number of moles? And that ultimately leads us to one more piece of information, one more quantitative piece of information that we're going to have to be able to solve for, and that's called molar mass. Now, to picture what this is, let's go back for a minute to that word mole. Now, mole, and please jot this down, is simply a way of quantitatively describing how much matter you have. Now, that brings up another word, a word that I expect that you guys know what it means. It's a word you've been learning since elementary school, but that's matter, and matter is simply anything with mass and that takes up space. In other words, it's everything you see around you, right? Everything you see around you, whether it's your textbook, whether it's the appears to be empty space that is the air, whether it's the person sitting next to you, maybe it's what's inside of your your water bottle at your table that you're drinking. All of those things are matter. It's anything that has mass and takes up space. And a way that we quantitatively describe that matter is something that we call a mole. Now, to understand what a mole is simply this. A mole is the mass of an element in grams. Or you could even say the mass of an element or compound in grams. Now, the question is, where do we get this mass from? This idea of this mass is a word that we're going to be learning as we get into the next unit or the next section that's called atomic mass. And the place we get it from is actually from something that we call a periodic table. So what I'd like you to do is around the classroom at your tables are stacked up what we call periodic tables. And I'd like you to go ahead and take a minute, and I'd like you to find one of those periodic tables for me and have it in front of you. Now it's going to look something like this. So if you would, find a periodic table, and it's going to look something like this. You might have even looked at one of these before, maybe in another class. Simply what a periodic table is a table that organizes all of the elements, all the different types of matter, types of atoms that we can find in nature, in our universe, into an organized table, into an organized piece of information where we could figure out things simply by looking at them. Now we're going to spend more time on the periodic table further in this class. Right now what I want you to focus on is just simply some information that you might find, for example, in an A, right? I had asked you, my question to you that I had posed was, if you had so much mass of sodium, well, how many moles would that be? And I told you just a minute ago that what it meant to be a mole was simply what we call the mass of a substance in grams. So the question is, how do we know what the atomic mass of that substance would be in grams? And we find that on the periodic table. So go ahead and find sodium on your periodic table. And when you do, I want you to notice that when you look at sodium, that you're going to see that sodium has a mass of 22.99 grams. Now, interestingly enough, what does that mean? Well, as you look at sodium and you see that it says its mass is 22.99 grams, that is called one of two things. That is known as, so that 22.99 grams for sodium, that 22.99 grams for sodium, that's the molar mass of sodium. And we could find that for any element on the periodic table. All we got to do is look and find where its atomic mass is. So again, what does 1 mole mean? 1 mole is simply the atomic mass of a substance in grams. So you think about what we're saying there, and what we're saying now is that we have another relationship, right? This is a relationship. We're saying, based on this relationship for sodium, that for every 22.99 grams of sodium, we have 1 mole. Again, notice one more relationship that we have that we could use in solving some sort of dimensional analysis problem. And we could look at many other substances on that periodic table and look at their atomic masses as well, right? Like as simple as you could find hydrogen. Hydrogen is the very first element on the periodic table, and you would see its atomic mass, or molar mass, if you will, is 1.008. And you could keep going on, right? We could look at helium and see it's 4.00, lithium 6.94, and so on and so forth. And we could simply figure out the molar mass of any element by simply looking at what its mass is on the periodic table. So what would that mean? That would mean by seeing that automatically we know how much mass of that element is in 1 mole. That's what molar mass is called. So how could we use that? Well, let's just make a note of a few things. So the mass of a mole of a substance is the atomic mass of that substance. How do we find that? We find that by looking at the periodic table, right? The periodic table that you have in front of you, that you are looking at right now, you could find the atomic mass of any element by simply looking and finding it on the periodic table. So let's just take sodium. Sodium, we just said, we see that 1 mole of sodium is 22.99 grams. We could do the same thing with chlorine. So find chlorine on your periodic table. Symbol is Cl. And you're going to see that chlorine, Cl symbol, has a mass of 35.45 grams. So what if I asked you for the molar mass of sodium and chlorine together? Well, sodium chlorine together is called sodium chloride, which is really just NaCl. So the question is, if we all of a sudden put those together, what would the molar mass of Na and Cl be? Well, if we're not putting them together, we could simply add those masses together. We've got the mass of sodium. We've got the mass of chlorine. Sorry, that should be 35.45 grams. Add them together, and we can get the mass of what sodium chloride should be. And I believe it's 58.43. Yeah, 58.44. Sorry, 58.44 grams of sodium chloride. So again, how did we do that? We simply found the molar mass of each element, and that allowed us to see what the molar mass of the substance was as a whole. Alright, so let's consider that, and let's do a few. Let's look at a couple different substances and see if we can figure out their masses. Let's look at a couple of these kinds of problems dealing with molar mass, and then I'll have you do a couple of them on your own. So let's just start with the very first element that's listed on here, F. Now F, if you look on the periodic table, F is really just fluorine. But go ahead and find F on the periodic table for me and see if you can find what the molar mass for fluorine would be. When you find fluorine on your periodic table, it probably says something like 18.9998, or it might even say 19.00. So simply put, we could make a note for fluorine and say that fluorine has a molar mass, so its molar mass is 19.00, and remember, we said that the units for molar mass are grams, right? We said it's 19.00 grams, that equals 1 mole of fluorine. So 19.00 grams of fluorine equals 1 mole of fluorine. Now I want you to notice something that I've been doing as we've looked at some of these molar masses thus far. And I want you to notice that what I've been doing is I've been writing all of these molar masses to the hundredths place. And the reason I've been doing that is for consistency. So I'm going to ask you to do the same. Alright, so anytime you're writing a molar mass, I'm going to ask that you simply round that molar mass so that it is written to the hundredths place. Okay? Alright, let's do another one. So let's just do the next one, which is O2. Same idea, so O2. So we look on the periodic table for O2, and as you look on your periodic table, you're going to find that oxygen has a molar mass of something like 15.9999. Now again, if we were going to round that to the hundredths place like we've just been talking about, oxygen has a molar mass of 16.00 grams. But now I want you to notice something here, because I want you to notice what we've also got to consider as we're looking at determining the molar mass. Notice this little 2 here. Now this little 2, that's called a subscript. And what that little 2 tells us is it tells us how many we have. So it tells us how many of those atoms or that substance that we have. So if we have not just one of those oxygens, but we have 2, then what we would simply do is we would simply take that 16.00 times 2, and now we're going to get a mass of 32 grams in 1 mole. Again, why did we do that? Because we didn't just have one of those oxygens, we actually had 2. So by taking it times 2, we're saying we had 2 of that mass. Alright, I'm going to give you about, let's say 5 to 10 minutes, and let's go ahead and see if you could find the molar masses for these 2 substances listed at the bottom. Okay, so let's just take a look at these. If you had a little bit of trouble with them, that's okay. I just want to show you how to go about setting them up, how to see what the molar masses of these two substances would be, and then we're going to take this and we're going to add one more step to it. Because ultimately the reason we're going to do this is to answer that question from the very beginning, which was, if we know we have so much mass of a substance, could we figure out how many moles we have? So let's just see if we can do that. So let's just take a look at this next one. Now H2O, I don't know how many of y'all know what H2O is, but H2O is really just water, okay? So anytime you see H2O, we're really just talking about water, but the question is, you know, what is the molar mass of water? So let's just see if we can figure it out. So let's just start with the hydrogen. Hydrogen, we see on the periodic table, has a mass of 1.01 grams. Now again, as I had just mentioned to you, I'm going to ask that you start rounding your molar masses to the hundredths place. That will just ensure consistency. So you might have noticed that the mass for hydrogen was like 1.008. So I just simply rounded that to the hundredths place and I said 1.01 grams. But now you should tell me that there's not just one hydrogen, there's two of them, right? That's what that little subscript means. It's saying two hydrogen. So we're going to take that 1.01, we're going to take it times 2, which means we have a mass for hydrogen of 2.02 grams. Alright, but we don't just have hydrogen in this substance, we also have oxygen. So let's go ahead and see how much we have for oxygen. Oxygen's mass on the periodic table, again, rounded to the hundredths place, is 16.00 grams. So really we just have 16.00 grams for oxygen. Put it together and it gives us a total mass for water of 18.02 grams. Now again, where does that mass come from? Well, it comes from the fact that we have one oxygen with a mass of 16 and two hydrogens with a mass of 2.02. Now, one more thing, remember what this number means. It means that there's 18.02 grams of water in 1 mole of water. That's the idea of molar mass. Now remember that what that ultimately gives us then is what we call a relationship, right? And we're going to use those relationships in just a minute. Alright, let's do one last one. Iron, this one should be pretty simple. There's only one of them, so let's just find it on the periodic table. So take a minute, find iron on the periodic table for me. Alright, so we find iron on the periodic table, and when we find it, we see it says its mass is like 55.845. So molar mass of iron is what? It's 55.85, and that's grams in 1 mole of iron. And so we're done, right? We've simply found what the molar mass of iron was. It's 55.85 grams in 1 mole. Alright, so now let's take this idea of molar mass and let's apply it. Let's say this was our question. How many moles of sodium are in a sample of 14.1 grams of sodium? Now, how do we know that this is a dimensional analysis problem? Well, let's go back and let's remember, a dimensional analysis problem will give us two things. It will give us a known and an unknown, right? It will give us something that we're starting with and something we're trying to go to. So let's just start with, what's the known? Remember, the known is always given, so our known in this case, 14.1 grams of sodium. Remember, the unknown is always the question, so how many moles of sodium, right? So our unknown is moles of sodium. Alright, so let's talk about what we can do now. Well, remember, next step is a relationship. So we need a relationship between that known and that unknown. Do we have a relationship that compares grams of sodium to moles of sodium? And we do, because we just talked about it. That relationship is called molar mass. In 1 mole of sodium, there's how many grams? Well, we look, we find it on the periodic table, and we see there's 22.99 grams of sodium. Alright, so we can now look at what our conversion factors are. Our conversion factors are either 1 mole of Na per 22.99 grams or 22.99 grams per 1 mole. Alright, and now it's just a matter of a conversion. So let's start with our known. Our known is 14.1 grams of sodium. Remember, we're trying to go into moles of sodium. That's our unknown. So which conversion factor is going to allow us to do that? It's got to have grams on bottom to get rid of the grams and moles on top. And that is this one, right? So 1 mole per 22.99 grams. All right, so take a minute and solve. How many moles of sodium are in 14.1 grams of sodium? And when you solve, you should get a number that looks something like this, 0.61331, and you could go on and on and on, right? But we want to round it based on sig figs. So based on sig figs, there are 3 in that number, 4 in that, which means 3 is the least amount. So it's 0.613 moles of sodium. And that's it. That would simply be a dimensional analysis problem that would allow us to go from grams of a substance into this new concept that we call moles. If you should have any questions about this material, please do not hesitate to ask. Tomorrow in class, you will get a chance to practice using this concept to solve a problem dealing with a specific substance, also called chalk. And then from there, you'll get some practice problems that you'll be doing as a part of a review activity that will ultimately prepare you for your exam that's coming up. But otherwise, then that will be it. This is the last section in this unit. This section ultimately is meant to kind of transition us from talking about measurements into talking about matter, talking about atoms, and really starting to understand what chemistry is. If you should have any questions, please do not hesitate to ask. Otherwise, I hope you have a great day, and I'll see you tomorrow.